Hi everyone, are you able to hear me and see my screen clearly? Great, great. All right, so welcome to the session on Big Data with Hadoop and Spark. So instead of going ahead with only Spark, I thought that we will have an introduction with both. So this session is going to be an introduction to Big Data. By the way of Spark and Hadoop, I'm going to cover the why, what, and use cases of big data in the first half. The session is going to be for 3 hours with 10 minutes break in between. And in the second half, I'm going to cover the Spark and Hadoop architecture. And then we will do a hands-on if the time permits. All right. So even if you are from non-technical background, please stay in the session. This is going to be an overview. Only the hands-on part you may not get comfortable with, but rest of the session is going to be generic and is going to be non-technical. This is the only session where we have more theory, but rest of the sessions are more hands-on. All right. Great, great. So please introduce yourself using the chat window while others are joining. And since the session is going to be an international, as in people from all across the globes have joined the session, so please avoid the local language. We prefer the English to be the main language here. Please introduce yourself using the chat window while everyone is joining. Session is being recorded, and recordings along with presentations will be emailed to you to the same email with which you had done the RSVP. This is the first of 20 sessions on big data with Hadoop and Spark. Though this course is going to be on big data with the Spark, the second session will focus on the Spark. And this session helps you understand the big data technology stack. So if you're just looking for understanding what is big data and how is Hadoop and Spark and the whole ecosystem related, probably this session will be very useful to you. Everyone except myself is muted, so please ask your questions using Q&A window. So there are two windows that you'll see. One is called Q&A window, and other is called the chat window. Okay, so please provide your introduction using the chat window while ask questions to me using Q&A window, because chat window has just too many messages. It's difficult for me to read those. And I'll be reading out the questions, or will be selecting the questions while answering. So since there are going to be quite a few questions and we promote lots of questions in these sessions, keep your messages short and avoid the chat language. All right. So a question from Pranjali is before starting, let me just take a few questions. A question is, do we require any installation prior to this session? No, you don't require. And for the entire course, you don't require any installation. The good part is that we are the pioneers of the cloud-based lab, specifically in big data. And because of which you don't require any installation, you can just start using our lab, and all you need is a browser, a functional computer with internet, and remaining is you don't really require any installation. All right. Great, great, wonderful. And so you all you need is a browser and fully functional computer for the entire course. And this entire course is very, very hands-on, and it's going to be this first chapter is only the one that is theoretical. Okay, I'll try to do hands-on towards the second half. And okay, next question is from Anup. What type of OS is required? Any OS is okay, whether you are on Mac, whether you are on Windows, or you are on Linux. Any OS is okay. Just that the tools that we use as part of this course may not work from the browser of the phone or an iPad. So laptop would be required mostly for doing the hands-on. Okay. All right. A question from MI is that, can you please clarify whether Spark can be used with SQL only, or do we require Python or Scala? All right. So though I'll be going deep dive into Spark and the ecosystem towards the second half. In the second half, I'm going to talk more about the stack about Spark. And there you will learn that Spark can be used using Python, Scala, Java, or SQL, or any other programming language. All right. So I'll be covering that part towards the second half when we talk about the ecosystem. A question from Gonzalo is that, can we access to the recording of the class after it is finished? Is that your question? After it is tempered? Probably you mean to say that after the class is over, can we access the recording, right? So yes, this recording will be shared with all of you. All right, it'll be emailed to us. So our question is, when will the session be emailed to you? The session will be emailed probably in 24 hours after the completion of the session. Okay. Wonderful, wonderful to have a great audience in these sessions. These sessions are basically quite popular globally, and we have had wonderful, wonderful audience. The question is, how do I get access to CloudX Lab development environment? You can actually, there are multiple options that you can do. You can go over to the CloudX Lab, either take a subscription of few months or just take a free trial. Free trial ends, free trial is for 7 days. 7 days is a huge amount of time where you can try out various tools. If you're already comfortable with big data tools, Linux, and so on, you can just take the CloudX Lab environment, and along with that, you will get lots of free tutorials, like free tutorials on Scala, Python, Linux, and so on. So take a look at that. And so you can just take a free trial or take a 1 month subscription, or you can refer your friends, and you will keep on getting the lab extended for free. A question from Rivanshu is that, do we get a certificate of attendance for this webinar? So we can, yes, we can give you the certificate for attendance for this webinar, and just drop us a message that you require the certificate. A question is, will the slides be available after the session? Yes. That's something we make sure that we share the slides with all of you, so that you can, if you want to present it to your team or your friends, it's completely okay with us. A question from Tejaswini is that apart from hands-on with CloudX Lab, if you want to practice it in our system, do the course cover any solution tutorial? We do help you with the basic of how to install. Also, we have created a video on how to install the entire system that you can take a look at our blog. Perfect. Perfect. So we help you with a couple of things. One is you can also try out something called virtual machine installation, but that requires a lot of hardware. So I do not advise you that. So instead, I would advise just take a free 7 days trial and then get started. All right. So Alan and Emma, you have raised your hands. Do you have any other questions? All right. So great. Great. A question from Salem is that I'm new to big data. Is there any prerequisites to study this? No. So so you don't require any. This course is very fundamental. This particular session is very fundamental, and it's not it. First half is most likely going to be entirely non-technical, non-hands-on. So it'll be completely okay for you the entire session. All right. All right. Wonderful. Wonderful to have people from all across the globe, from the US, from Australia, from Hong Kong, from Indonesia, and so on. Great. Great to have all of you in this session, along with people from India and California. Wonderful. Wonderful. We have people from Uruguay and Toronto. Great. And we have people from Spanish also. Spain also. Yeah. All right, great. How many students in the Instructor Live course? Before starting, I'd like to answer this question also. So, so generally we don't go beyond 20 to 25 people. 25 people is our upper limit in one live course. Though self-paced course is completely flexible, it's up to you. It's as per your time, you can take it up. All right. Wonderful. Wonderful to have great audience, and let's get started. At CloudX Lab, we are making learning fun and for life. And so by the way of videos, quizzes, hands-on projects and case studies, and all of these based on real life use cases. The core focus at CloudX Lab is learn by doing. This is the only session, the first session, that is more theoretical because it is aimed for larger audience. People from all backgrounds attend these sessions. And we have the largest community globally on AI and big data. And of these sessions are the sessions where you have the maximum number of audience. I mean, this kind of audience you would not see in any other webinars. All right. So right now we have close to 81 participants, and the participants might go up to 100 and so on. Okay. All right. So all of these are based on real life use cases. What I'll do is I'll break it into the discussion into okay. All right. So is my voice not clear? All right. So in case it's clear for some and not clear for others, there must be some network related problem. Please move near to your Wi-Fi or see if you want to use a different 5 gigahertz kind of a zone. All right. Generally, if the Wi-Fi is crowded, you would find that there is a lot of interference, right, on the normal one. So please check that, and in case you're still facing problems, just let me know. I would love to figure out like how can we make the experience better. All right. So a question from Arth is, I'm from Australia. My question is, big data and Hadoop is useful in every business or medium to large? Yes, that's right. So when you have large scale data, the big data tools and technologies can help you solve those. All right. Great. So I'll be, the way we are going to have this discussion is in 30 minutes part. So up to 7:45 IST, I'll be doing theory, and then I'll be answering your questions. All right. So great. Keep asking your questions, and whenever you have a question, please ask. Don't worry about whether your question is smart or not smart. Almost every question is good. Almost every question is important. So please feel free to ask. And there is no such thing called dumb question or easy question. Every question is more important. So please ask the questions, and that's something we promote heavily. Okay. So I'll be taking up the questions at in 30 minutes. I'll do 30 minutes theory, and then questions, then theory, then questions. So that way we will be having enough momentum. And I'll try this session to be useful to all. And I'm sure that in next 3 hours, you are going to walk out with something new, something that would be useful in your career. All right, let's move ahead. So we basically believe in a lot of hands-on, and that's the reason why we have created something called automated hands-on assessments. So the way it works is that there's a problem statement, and then you do the hands-on in the lab. It checks automatically and gives you go ahead or fail. All right, so that's the assessment. So like, for example, this is the simplest one, and this is a little complex one. So here what we are doing is, on the right hand side we have a notebook, and on the left hand side we have a problem statement. This is an extremely simple problem statement. Okay, so here we are saying that define access 10, and the moment we do that, it will check and give you the reward saying, hey, good job. All right, so this is automated hands-on assessment. Though it may sound very obvious and simple thing, but the important part is that these hands-on assessments have improved the user engagement, or you can say the learning, because they don't have to, the learners don't have to rely upon somebody to answer their questions. Okay, so they can keep on trying things and keep on getting the rewards. All right, so this is something that we have done unique in the case of Cloud Scala. And I'm Sandeep Giri, and I graduated long back from IIT Roorkee, and I've mostly worked in my career on large-scale computing. I've worked with companies like D.E. Shaw, InMobi, and Amazon. At D.E. Shaw, I worked, I joined in 2002, and that was my first introduction to the humongous data. At D.E. Shaw, my introduction to big data happened, though the term was not there. We never called it big data. We called it we called it grid computing and distributed computing at the point of time. So at Disha, the kind of data we were churning were far bigger. Those who are not aware about Disha is a company, was one of the really highly technology company. The Amazon founder, even Jeff Bezos, was also working at Disha before starting Amazon. Then I founded a company called T-Bits, whereby we built software for power plants. And then I worked with InmoBee to process their 200 terabyte data. And then I worked with Amazon for their the detailed page, the one from which you do the buy now on the mobile. That's the one I built. And at heart, at the heart, I am software engineer, and I love explaining technologies. That's the reason why we started CloudX Lab. So most of my career I've spent in the large scale computing, and I enjoy explaining technology to everyone. Therefore, we started CloudX Lab. At CloudX Lab, we are helping people learn the big data and machine learning and AI. And at the same time, we are helping many industries, many companies to solve their machine learning and big data related problems. The course objective is basically learn to process big data with Hadoop and Spark. Hadoop is optional, it's up to you. You can take up the self-paced course. Spark is going to be live instructor the way we are talking. Okay. And the format of the course is exactly this way, that you ask questions and I answer your questions. Since today there are just quite a few people, therefore we are not answering too many questions right now, but we will answer the questions in more details in some time. But most of the course is focused on answering people's questions, answering any questions. And that's the reason why most of our learners have been really successful in the industry. Most of our learners have been in the technology leaders in the industry. Okay, be it say IBM's Bluemix leadership team, they are our learners. Be it the technology heads of various companies globally, they are all mostly our learners. All right. So we have been lucky to have wonderful learners globally on, and you will notice that if you look at Quora and if you look at say LinkedIn, you'll find that lots of people have written great things about CloudX Lab. All right. So and I would like to start the discussion with defining what does it mean by data. So practically almost everything that is recorded and kept in certain storage is data. When we are writing on pen and paper, with pen and paper, that's also data. When we are working on Excel sheet, Microsoft Excel sheet, that's also data. And when we're taking photo of somebody, that's also data, right? Now, the way we define data in the beginning, why we want to define the data in the beginning, because the selection of tools, the choice of tools is a function of what kind of data do we have, right? So generally, there are three buckets. There are three classes of data. One is structured, second is unstructured, and third one is semi-structured. Semi-structured is in between the two. So structured data is like the data in the database or in a well-formatted way, where you know clearly that these are the columns. Data, in the structured data, you have columns and rows. It's like a tabular structure. And in this tabular structure, you have a clear definition of what is, you have a clear definition that what is a column and what is the data type of the whole column. The whole column, in case of structured data, has the same data type. All right, so that's the structured data. The advantages of structured data is that we can do the processing of the data really easily. If you have, let's say, car sales data and you would like to quickly find out the reason why sales of the car, if the data was in the form of a table, if the data was structured data, it'll be easy to just run a query in a moment of time and you'll get the results. I mean, the coding time, the work time, the development time will be really low. So structured data has got amazing advantage of quick to process. And once you have a structured data, you can use SQL kind of queries to process it. You can use a very simple language such as SQL. SQL stands for Structured Query Language. So basically great for processing the structured data. So that's the definition of structured data. And on the other extreme is unstructured data. In unstructured data, we don't have a clue about our columns or data types. In midway is the semi-structured data. Semi-structured data, we know that what are the columns, but we are not sure about their data types. Like, for example, data in say, CSV file, comma separated values, we call that CSV. The data in CSV file is essentially, we have a plain text file whereby you have the data in the form of A, comma B, comma C, and so on, and then new line, then second line, and so on. So this format is extremely user-friendly in the sense that it can be opened in any kind of editor, whether the text editor or the spreadsheet and so on. But the only challenge is that we do not know the data type, or we are not sure about the whole column having the same data type. So this kind of data is called semi-structured, where we know that it has got some structure, but we are not sure about, or we are not confident, or and there may not be a consistent structure, like it may not have the same data type all throughout the column. So such a data is called semi-structured. We know the fields, but we do not know their data types, right? This is called semi-structured. The unstructured is the other case. In case of unstructured, we have the plain text data or raw data, whereby we do not have the information about fields, or in other words, you can say that we can't really represent the unstructured data in the form of table. Okay, so that's called the unstructured data, right? All right, so I hope that answers your question related to the structured data, related to the data, the types of data. Yeah, right? All right, so when you, the important part is, why do we need to talk about structured or semi-structured or unstructured? Because based on the data type, we generally use the tool selection, okay? Now, translating unstructured or semi-structured to structured is a very, very common process in industry, and we call that ETL, extract, transform, and load. There are many tools that help you do that. There are many tools, including the tools from Microsoft, the tools from Informatica, that help you do this translation. But the challenge is that when this data becomes bigger and bigger, this ETL becomes impossible using the existing tools. And that's exactly where big data tools come in. So big data tools like Spark or Hadoop and so on, they all help us in, in storing such kind of data as well as doing the ETL on this data. All right. So I'm going to talk more about that very soon. Okay. Now, before we proceed, the other term that'll keep coming is called distributed systems. What is distributed systems? Distributed systems are basically the groups of networked computers that interact with each other to achieve a common goal. So it's basically the groups of networked computers that interact with each other to achieve a common goal. That's distributed systems. Okay, so the more important part here to understand is that the common goal has to be broken down into parts such that the parts of the goal are achieved by individual computers, right? If we have a, let's say, a computer center and where we have all the computers connected, they may not, that's not necessarily a distributed system because they're not achieving a common goal. All right. Now, distributed system has been one of the reasons why we are able to do the large scale computing. Distributed systems are the reason why we have so scalable services from Amazon, from Google, from Twitter, from and so many, right? So distributed systems is the reason why the whole big data has started. So if you, as we go ahead, you will realize that when we say big data tools, we are actually talking about a tool that can help us in distributed computing. All right, just to check, please post this in your chat, in the chat. How many bytes are there in 1 petabyte, just to be on the same page? Yes, it's okay to search and look up. All right, how many bytes are there in 1 petabyte? Yes, okay, 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 that's good. 1 kilobyte has 1024 bytes. 1 megabyte has 1024 kilobytes. 1 gigabyte has 1024 megabytes. 1 terabyte has 1024 gigabytes. And 1 petabyte has 1024 terabyte, right? So approximately this is the value. And yes, I have copied it from Google. All right. So okay. So in other words, the way you can remember is that kilo, mega, giga, tera, and then peta. Okay. So and it's basically a multiple of 1024. All right. I think, Shailesh, it's going to be, I think, 2 to the power 50, isn't it? Okay, so that's wonderful. Great. Most of you have been able to answer the question, so let's move ahead. This was just to see if we are all on the same page. Okay. Can you take a guess how much data Facebook stores in one day? Anybody? All right. So they store about 600 terabyte. Yes, that's right. Approximately that. All right. So the big question that before we start is, what exactly is big data? Anybody? Yes? All right. Great answers. Let's move. Okay. So the entire course is about big data. And before proceeding, I would like to have the definition where we all agree on one definition. Okay. So let me go ahead. So most of you are right. That's great. Now, so the in very simple words, the data of very big size that you cannot process with usual tools. Okay, what does it mean by usual tools? Usual tools are like your file system, your your database, and for such a data, you require distributed system or distributed architecture. Meaning, when you cannot process your data using your usual tools, when using a single computer, the tools that cannot run on multiple computers parallelly, then we call such data big data. And the data could be structured or unstructured, but if you require many computers to process it, then we call such a data big data. Big data, big data tools are basically tools that can run parallelly on multiple computers to solve a problem. All right? So that's the most important part. That's the most important part. Even very simple looking problem become almost impossible when the data is big. Imagine that, I'll talk about it soon. Imagine that you have to do really simple computing like counting words or counting letters or checking whether we have vowels more or letters more, consonants more. Even such a simple problem becomes almost impossible to solve if you have if you have traditional systems, like if you have like normal file system, your own computer. Even if you are using, even if you are using really high-end computer, even then it becomes impossible for a single computer to solve such a problem when the data becomes really huge. And really huge doesn't always means volume. I'll talk about it. It also means the the velocity and so on, right? So the most important part is that for big data, we require distributed architecture. For big data, we require distributed architecture, or you can say parallel systems. Okay, so there are three parts to the big data story, or you can say the three characteristics of big data story. There are almost veracity and so on. I'm not going to touch it. Okay, so the traditional definition of the big data is this, though it's a classic definition of data, but just so that we all are talking about same thing, let's just go over the definition. So the characteristics of data are volume, velocity, and variety. Volume is the data at rest, meaning the problems associated with storing the data. When you have huge data, such as the storage of the logs of website, or imagine you're running the Gmail and you have lots of data, where do you store? A typical storage of one computer would be at most like let's say 2 to 4 terabyte, or maybe up to 8 terabyte, but nothing beyond it. It becomes impossible to store 100 terabyte data per day using individual computers. You would require many computers to store such a data, storing such a data reliably. So the volume is a characteristic by virtue of which your data might become big data, or because of volume, we might end up with we might need a distributed system. The second part is the velocity, whereby we have a situation, or we have a problem statement whereby we have to handle the fast incoming data. All right, fast incoming data. Like for example, right now, when I'm giving this webinar, is being copied to 89 parallel users. Okay, that means that this is a very fast incoming data. It's being copied to all, and so the problems involving the handling of data coming at fast rate, we call that velocity. The number of requests being received by Facebook, YouTube, Google Analytics, and so on, those are example of velocity. The third one is variety. Now this is an interesting part. So variety is the data in many forms. Okay, so it's not only because of volume or velocity that we require distributed computing. It's not because of volume or velocity. It could be the third case also. The kind of problem that we're solving could be complex. Say, for example, we have to solve a problem related to maps. We have to go from point A to point B, and we have to find out the best possible routes. Even though volume-wise, data could be small, velocity-wise, we don't have that much of data coming in, but because of complexity of the problem, because of the structure of our data, we might require large-scale computing or big data computing or distributed computing. And therefore, variety is another characteristic. Variety is another characteristic whereby we might be pushed to use a big data system. Say, for example, let's talk about the other use cases. Let's say coming up with recommendations for users, right? Even if the data is small, the kind of computing it involves is actually huge, because you have to compare every user against every other user based on many parameters and so on. And we will have to have huge data in order to give recommendations. Therefore, variety is again the very important characteristics of big data, right? So let's move ahead. Now, here's a question to all of you. How much time does it take to read 1 TB from hard disk? Just a number. You have a hard disk. Hard disk is a place where you store all your data on your computer, right? You might be having huge amount of memory, a huge amount of movies or songs in your hard disk. So my question to you is, how much time approximately does it take to read 1 TB from hard disk? Yes, that's right. So it depends upon the read speed. Please feel free to say, okay. So just give a number. It's okay to be wrong. Take an approximate average hard disk. All right. That's right. It takes few hours. Good. That's the right way to do the calculation you're asking. And Ali. All right. So yes, it'll take few hours to read 1 TB data from the disk. Okay, that's very important because it doesn't depend upon what kind of data are we reading. It doesn't depend upon the kind of data we are reading. It depends upon how fast is the hard disk, how fast it can rotate. Hard disk is basically just like the cassette recorder you must have seen. It's a magnetic thing and it rotates and the header moves. So there is a header which reads the data from the hard disk and we read using that. So basically when the hard disk rotate, we are able to read the data from it. So approximately 6 hours is the time that it takes to read the data from the hard disk. Now, another question to you, all of you, is that if you have to count just the vowels in 1 PB data every day, do you need a distributed system? If you have to count just the vowels, all you need to do is read the data, check each character if it's vowel or it's consonant, and then count it, increase the count, that's all. Okay? Right. So yes, we require distributed system. Why? Because as we just discussed that when we are talking about reading 1 TB data from hard disk, imagine that we had, let's say, 1 PB hard disk, let's just assume for time being. If we read that, it will take probably 6 multiplied by, say, 1,000, that is 6,000 hours, right? 6,000 hours, and therefore, reading 1 PB data on one computer is going to take so much time, even if we had such a computer which could store 1 PB data, right? So even for storing 1 PB data, you require distributed systems. Okay, so here the volume will become the first issue, then complexity, the third one, the variety will become the next issue. So important part to understand is that when we have 1 PB data, that too you need to process every day. You cannot get it done using one computer. You require distributed computing. You require many computers to handle this 1 PB data parallelly. So yes, we require distributed systems. We need to have many computers with many hard disks, so and connected to each other, so that we can store this 1 petabyte data parallelly. And once we have stored this data into many computers parallelly, we have broken down 1 petabyte data into 1 terabyte, and we got, let's say, 1,000 computers. Then we can do this work really fast. We'll be able to get this done using 1,000 computers in few hours. All right. So when we say 200 terabyte data, it's actually a big data. Okay. So I mean, when the data becomes big, and it can be handled by a single computer, the entire learning, the way we have thought about data, the way we've thought about computing changes entirely. My interesting experience was long back at a company called D.E. Shaw. So we wanted to process some data, and that data was changing every week. New data was being generated every week. So I said, what is big deal about it? We'll just download it over the wire. So I was working in India, in Hyderabad, and my data was in New York. Now, when we started downloading, we realized that downloading the data will actually take more than a week. Therefore, we chose something very different. We actually got the courier, physical, we got the data transferred physically using the ship or the flight. And that was apparently faster than downloading. So you can think of it that the ship was faster than the plane. Ship was faster than the speed of the electron when it comes to the big data. So the point I'm trying to make is that the moment the data starts becoming bigger and bigger, your existing systems, the way you've thought about data, kind of becomes kind of changes, and the entire philosophy changes. The way we have been storing the data, the way we have been processing the data, entire thing changing. Even the way we have been transporting the data, it changes. So yes, thank you, Iraqi. So yes, never underestimate the bandwidth of FedEx truck loaded with hard disk drives. So that was my first experience long ago, and around 17 years ago. And I was like amazed that even though we apparently had a great bandwidth, but the kind of data we had could not be downloaded in a week over the internet. So we got it shipped. That's a very important part, that when the data becomes big, you can't use your normal common sense. The common sense that we had was not really useful in handling such a big data. And that's the truth about handling most of the big data. You'll be amazed at the kind of strategies that we use in order to handle the huge data. Just like Newton's laws in physics do not apply when something starts moving so fast. And similarly, the classic ways of handling data do not apply when the data becomes big data. All right, so here is a classic graph whereby we are showing that the internet, the beginning of digital, after the beginning of digital age in 2002, that was my year of pass out, where the data started increasing exponentially. Specifically, the electronic information, the electronic data started increasing. The digital data started increasing enormously, while analog storage kept on shrinking. Analog storage is the paper, film, audio tape, and so on. But the digital data kept on increasing. And it has increased exponentially. So why are we talking about big data now? Why the data has increased tremendously? One of the reasons is smartphones. Today, the device that you have in your pocket is faster than and more powerful than supercomputers. supercomputers of olden times, of supercomputers of 2002, was slower than the phone that I use right now, the phone that I'm using for playing the funny games. All right. And the second is the connectivity, and third is the application. So I'll take a Q&A break. So let me just answer your questions. I was supposed to take it at 7:45. Okay, so let me go back. Before moving ahead, I'm going to answer your questions. So okay. So a question is from Neil. Is it required to complete the Hadoop self-paced course before starting the instructor live Spark course? Okay, good question, good question. So not necessarily, but you should do that in parallel, okay? Because in Spark course, what I'm going to do is the topics which are overlapping with Hadoop, in which I really require the understanding of Hadoop, I'm going to give a quick overview and an understanding of those topics quickly, and then move on to the Spark. As part of this course, that's what I'm going to do. All right. So not all topics of Hadoop are required for learning Spark. The HDFS and Yarn are two important topics that would be useful, but it's not impossible to move ahead with Spark. Okay, so in summary, that it's not really too mandatory to take up the Hadoop course, but it'll be great, nice to have to finish the Hadoop self-paced course. Okay. A question from Anup is that big data is the problem and Hadoop is the solution. Hadoop is one of the solutions. I'm going to talk about it. Okay. Great question. So is there any guideline or best practices for designing pipeline for some specific or general use case? So there's no straight away answer to this, because designing pipelines is a hard and interesting problem. Okay. And because the definition of pipelines is different for different companies and different individuals. So there's no, I mean, there are guidelines, but it would not be quick here. So what I'll suggest is that come over to the discussion forum. This question deserves far deeper treatment than discussion here. Okay, far deeper treatment as in I'll have to break it down into parts, like what are the possible solutions and what are the guidelines to use each of the solutions. All right. Come over to the discussion forum. We have very vibrant discussion forum. Okay, so it's let me just try to see if I can. Okay, so here is the discussion forum. Come over. I would love to answer this question. Okay. Let me copy paste this URL to all. All right. A question from Tejaswini is that, so just for clear understanding, distributed computing existed before big data problems came up, and they used the distributed computing solution to, yes. So that's right. The big data term was actually came pretty late. And specifically, the term comes from a paper that was published by Google on MapReduce. They call it obscenely big data. Okay, they call it obscenely big data, and the word big data probably picked up from there. But before Google's, the big data or distributed computing was being used, and in distributed computing, the companies like D. E. Shaw were doing pretty good work. They have good number of papers. The place where I worked, And we had the largest cluster at that time. And we did have our own mechanisms to distribute the workload to many computers. All right, great question. So a question from Hari is, what about Scala? Scala is just another programming language, a simplified Java, you can say. A question from Oki is it compatible with Windows 7 64-bit? So yes, you can use Cloud Scala using Windows 7. That's pretty good. The question is, can Hadoop be installed on Windows 7 64-bit? You can install you can install Hadoop's virtual machine if you are really interested in installing, okay, on your computer, but it doesn't make sense to install distributed computing system on a single computer. You can only, you can only emulate it. You will not really get the feel of it. A real feel of a distributed system is to be experienced using multiple computers. That is either using cloud or using maybe solutions like you assemble multiple computers at your home, or you can also create multiple virtual machines on your single computer and then connect them by the way of Hadoop or Spark. All right, so great question. So moving ahead, a question from Anup is, what is data lake? Data lake is basically a concept whereby we say that this is our storage whereby all kinds of data will be kept here. Just like in the lakes, the water used to flow from all across the city to a place. Similarly, we needed a place where the data from across the organization could be kept at a single place. What happened because of the standard computing, like the databases and the file systems, what happened was the data was kept on single computers. Because of which what happened was that the moment that one particular database will be full or will start reaching to certain limit, we'll create another database. That way, the data became fragmented. And you have to rummage around the organization to find out which table to use, where is my data, right? That kind of problem is solved by using a centralized data lake. A data lake under the hood is powered by many computers, okay? So it's a distributed place whereby we keep all the data, and then it's a single place where you can find or browse the entire data. That's the sole idea. And we can do the processing and so on. A question from Anup is, what is data warehouse? So what used to happen is, for processing the data, we will copy the current data to somewhere, okay, and then we will run the queries over there, okay. That's what we call it, a data warehouse. So it's where the live requirements were catered from the actually one database, and a copy of it was kept in a separate machine from which we can do the query. All right. A question from Neil is, how much time commitment is required per week for taking this Spark course? So every week we are going to have total 3 + 3 hour session. Like this session, this is a 3-hour session, and then there is a next session will be on every Saturday, Sunday of India time. For those who are in US, it's going to be Friday and Saturday morning. And the Spark course is going to have 12 sessions approximately. And that means 12 multiplied by 3, that's 36 hours approximately. Okay, why I say approximately, because based on the questions, based on the new topics being added to the course, the time might expand. Okay, so be aware that though we promised like 12 sessions, the sessions might become 14 or so. Okay. And that's something that, because we have to balance three things. One is the course should be should include the new topics. Second, the course must have the course. Everybody's doubt should get cleared during the course. Third is the time. So we let go of the time in order to meet the first three. So approximately it's going to be like the classes are going to be that much, but from your part, at least 2 hours weekly extra work will be required, because there'll be assignments, there'll be exercises that you will have to complete as part of this course. A question is, I understand this is jumping the guns, but are you going to talk about financial benefits? Yes, I'm going to talk about this. A question from okay is that after all of this session, do we get certificate? We can give you the certificate of attendance. Let me, yeah, we can give you, all of you, the certificate of attendance for this particular course. A question from Hari is, my question is whether Scala self-paced course should be completed before attending the course? No, I'll be taking up a crash course on Scala as part of this Spark course. We'll start with actually Scala. Next session is going to be on Scala, and then we will move on to Spark. Okay, so but it'll be great if you start going through this Scala self-paced. That'll give you a lot of questions to ask, and you can utilize the live classes better by utilizing the live classes for doubt clearing. Okay. A question is, what is difference between database and data warehouse? So data warehouse is made up of databases. Okay. That way you can think of. Question from Ravind is, if you're going to, if you're going for Spark, then which will be good programming language? Okay. So a good question. So I'll be discussing this again. Here, the important part is that the okay. So when we started the Spark course, we did it in Python. Okay. Soon enough, we realized that in industry, people are asking for Scala with Spark. The reason is that when it comes to enterprise programming or computing, what people ask is that people use a programming language which can be compiled, so that during the development time or during the testing time, most of the compiler level problems are resolved. If there is a syntax error, if there is some other simple issues, they can be caught at the compile time. So companies, specifically in the enterprise or product building, they didn't really prefer a language which does not compile, language like Python, to a very long time. It's only for the analytics and a machine learning kind of workload people used the Python and others. But in enterprise world, where you have to build a product, there using a language such as Java or Scala is preferred because it compiles and we get to know about the errors upfront. Okay, so keeping this in mind, we realize that the demand for Scala is going to go up. And the great thing about Scala is that it's essentially Java, but the syntax is very much inspired from Python, which means the syntax is very succinct and simple. That makes it a very good programming language for enterprises, that you got the robustness, speed, and the compile time from Java, and you got the simplicity of Python. Therefore, we decided to go with Scala. And the other advantage of Scala in case of Spark is that Scala is the first-class language from the perspective from the perspective of Spark. So the API is most updated. So it made a lot of sense to go with Scala. The other third reason why we chose the Scala for this particular course is a very important discussion because lots of people ask us, so we had given a thought. The reason is that if you know Scala, you can quickly switch to Python. But if you know Python, you can't switch to Scala. Okay. Therefore, it's very important to know Scala when you are trying to do big data computing in today's time. That's why we started with Scala. Okay. A question from Subabu is, please suggest any best book to learn big data in detail. I would suggest there is a definitive guide on Hadoop. And learning Spark is great for Spark. And the definitive guide of Hadoop is great for Hadoop. Okay. A question from Chandan, is tabular data stored in text files considered as unstructured data? That's right, Chandan. So until we load that data into a format where we are guaranteed about the structure, we will keep on calling it unstructured data until the point we load it. Okay? So until the point we map it or load it. So till that point of time, we'll call it unstructured. But it's a very good question. So yes, I said morning. Did you mean evening in the US time? That's correct, Neil. So it is going to be evening in the US time, this time actually, the one that we have right now. This is right now Sunday in India. In the US, it would be Saturday. And therefore, you can say that the class is going to be on Friday and Saturday evening in the US and Saturday, Sunday morning in the Asia. Okay. A question from Equip family is that is today just the intro or do we have? So I'm hoping that if we get time towards the end, we will do the hands-on. And the pricing, I would request that please take a look at the website. That would give you a good idea about the pricing. Okay. And yeah, so let's see if I get time towards the end, I'll do the hands-on. But this session is going to be mostly for a wider audience to get understanding of big data. And then we will go into from next session onwards, everything is going to be hands-on. And the way these sessions happen is that all of the people in the class log into the CloudX lab, and we work together. In case somebody is stuck, somebody is not able to move ahead, we project the screen to all other learners, and I guide them to solve their problems. All right, good question. So moving ahead, a question from MI is follow-up to, these are good questions, so let me answer these questions. And I'm sure that these questions are going to be very useful to all of you. Okay, a question is follow-up to the data lake question. Is the data lake inside HDFS or where is it stored and how is it processed? Good question. So this is the part I kind of missed. So data lake is a concept whereby the data from entire organization flows to a central place, right? But how to build a data lake? The best solution, the cheapest as of today, is using the Hadoop file system. That is basically a very distributed system to handle the volume. It can utilize hundreds of thousands of computers to provide a single data lake for the entire organization. And whenever needed, you can just add the computer and users wouldn't even notice. So that's a simple way of building the distributed file system or a data lake. Now, there are other solutions also that does the same thing. There are some commercial solutions and so on. Okay. A question from Sarah is that what advice do you have for someone who wants to start in big data area? I have experience in database analysis using SQL Server. Great. So since you have already a good experience as SQL, I would actually just suggest that either take up a self-paced course on big data, or take up a live course, just like this one. I think you will be able to move ahead pretty well. Most of the learners that actually move to big data come from your kind of good background, and it's going to be useful for you. All right. So a question is, what is data pipelines? All right. Data pipelines as in the data coming from one place, being processed and translating and so on. So generally when you have large scale data, when you have, let's say you have to solve a hard machine learning problem, build recommendations or do something, what you have to do is you have to process the data from one form to another, or transfer the data or transform the data from one form to another. For that, you generally create these pipelines. Okay, and again, data pipelines is a very concept. As a concept, it represents multiple things. Sometimes data pipelines is confused with the message queue. Sometimes data pipeline is only considered as um, the data pipeline is only considered as transport layers, and sometimes the data pipelines is considered as transformation. But the right way of thinking of data pipeline is that when you have to translate and transform the data from one form to another, you have to assemble multiple steps, and those steps are something we call that as a data pipeline. A question from OK is that, is data mining one of specialized job description in big data grouping? So in big data, what we do is when we have, let's say, a large scale problem in an organization, 95% of the time actually goes in framing the data, in basically cleaning the data and structuring the data and figuring out which data to use, figuring out how to access the data and so on. 95% of the time goes in that, right? And then once we have the data in a good form, then we can apply the data mining or machine learning algorithms to get the desired results. Okay, so ETL as well as data acquisition remains the larger problems when it comes to data. So the big data part, the one that this course is about, this helps you understand the entire ETL process on big data, along with helps you understand how to store, how to process, handle the data using various languages and using various strategies. Specifically, this course is designed so that when we talk about humongous data, the data in petabytes, you should be comfortable with solving that kind of hard problems. A question from Salis, is there going to be any hands-on in this presentation? I'll try towards the end if the time permits. All right. A question is, may I know the relationship between Scala and Spark? Scala is a programming language and Spark is a framework which can run your logic in the network. Okay, so which means that Scala is a programming language and Spark is something like a software, big piece of software, and to which you give your SQL or your code, and that Spark will basically run it. So Spark is also written in Scala. So Scala is more like Java, while Spark is more like Hadoop. All right. Calling semi-structured is more appropriate for files. So it depends on the kind of data we have. A question is, will you be an instructor for the live course? I'm hoping that it will, I'm hoping that I'll be able to take up this live course. Okay, most likely I'll be the instructor for this live course. A question from Active Family is that, any trial period in which I can check out the courses for a few weeks? Yeah, there are quite a few free trial courses. You can just look at them, and that would be good. Okay, that will help you out. So just take a look at our website and you'll get a fair amount of idea. Okay, a question from say, okay, so that's, thank you, Sudha. Okay, moving ahead, could you please explain in the terms like data cleaning, data compression, and data hashing? Sure, sure. We'll, as you go ahead, we'll do that in more details. Okay, so, but I'm not sure about data compression. Do you mean data compaction? Okay, so, all right, I'll talk about this towards the end. Okay, just give me some time. A question from Anup is, what is data mining? Data mining is basically mining the data for important insights. Most of the data mining techniques now are part of machine learning and data analytics. Okay, so that's data mining. And now a question from Vincent is that what type of format does Scala stored for data after ETL? Does Scala able to integrate with business intelligence tool such as this? Okay, so Scala is just a programming language like Java. Okay, probably you mean to say that what type of format is Spark stores the data after ETL. So so basically you can choose any format. You can keep the data in SQL databases after the ETL. You can also keep the data in the tools like, say, the HDFS, and in any format. So Spark allows you to keep the data in any format. That's the power of Spark. It lets you use any kind of systems. You can use the BI tools with Spark SQL and present the data using the BI tools. All right. Okay. Thank you, Sweta. Let me just, could you post this link to the chat? That's something that would be helpful for people. Okay. A question from May, how long does it take to learn Spark in general for someone who has no background in databases? So it might take you probably 1.5 months, or you can say not 2 months probably. It's going to be actually 2.5 months. I'm just calculating it. They're going to be 12 sessions, and every month we have like 8 sessions. Okay, so you can approximately say that it'll take approximately 2 months because there's a project and so on. Question from Madhu is, what is the specialty of Spark as compared to other competitors who are in the market? Quickly, it's pretty fast and it's really simple to use. Okay, and it's very sophisticated and powerful. That's one of the reasons. Okay, so let's move ahead. So those were wonderful questions. We'll again come back to the questions after 30 minutes. Okay, so let's move ahead. So we talked about why is big data important. The big data is important because of, before I move on to the class, my suggestion to all of you is that keep asking the questions, okay? If when I say that I'll be taking the questions again after 30 minutes, it doesn't mean that you should not be asking the questions. So whenever you get a question, please ask, all right? Great, let's move ahead. So, all right, so question is, why is big data important now? The big data is important now because we have got humongous data. And why we got humongous data? Because we got the powerful devices, the smart devices, and every device The manufacturer's goal is to make it cheaper, faster, and smaller. And then we got connectivity. Connectivity has become available, cheaper, and faster. Okay? And because of these two, there have been lots of innovations in terms of software. The fact that we are able to conduct this session today is because of connectivity and the devices. Okay, so because of these reasons, there have been a plethora of applications, and it has impacted the human life in many possible ways. Now, before moving forward, because some of you are from non-computing background, I want to give you an overview of the basics of the computing. So what do we need in order to process and store data? We need, inside a computer, we have something called a CPU. CPU is, the characteristics of CPU is the speed at which it can pick up an instruction and execute an instruction. Executing an instruction means picking information or jumping to another location, right? So the CPU, it's characterized by how fast it can execute the instruction. So the more instruction it can execute per second, the more it's powerful. Okay, so when we say gigahertz, it means number of instructions per second. Okay, so gigahertz means 10 to the power 6 or a billion instructions per second. Okay, megahertz means a million instructions per second approximately. Okay, so that's how you can think of it. The second characteristic of a computer, inside a computer, is the RAM, the memory. The memory is extremely fast storage. So when we are executing something, what we do is we take the file, load it in the RAM, or take parts of the data and load it in the RAM, and then we perform the operations. Okay, so before computing, we have to load things into RAM and then execute the instructions. The RAM has two characteristics: speed and size. The faster the RAM, the better it is. The bigger the RAM, the better it is, right? But the problem with the RAM is that it's too costly, and RAMs are not available beyond few gigabytes. Therefore, you cannot afford to load terabyte data in the RAM. Okay. Third one is the hard disk or the permanent storage or solid state drive. So when we are, so the other problem with the RAM is when the computer restarts, the RAM doesn't have, RAM gets washed away. It is cleared up, right? So to store things such that even after reboot, the things are available, we keep those in hard disk, right? Hard disk or solid state drive. The hard disk or solid state drive is characterized by two things: how big it is and what is the speed, right? Fourth one is the network. Network we did not ever perceive as the part of the computer earlier, but today it has become one of the very important component. Okay, so when we talk about big data, at least one of these components that you see on the screen, at least one of these will become the bottleneck. Okay, so the way we have always been dabbling as a computer engineer, that okay, hard disk is becoming bottleneck because it's slow to read. So what we'll do is we'll shift it to the RAM. We'll keep the more data in the RAM, and when RAM becomes full, we push it back here, right? And then when this becomes full, what we do is we move it to another computer in the network. Now, when we move the data to a network, for every processing, first we have to read from the network and then process. That becomes really slow, because of which the network becomes the bottleneck. In some of the problems, specifically the problems related to machine learning, AI, deep, so on, we'll talk about that later. So this one, the CPU speed becomes the bottleneck. Specifically, the problems involving say blockchain, the specifically problems involving the computing, the CPU speed becomes the bottleneck. Or let's say you want to find out the best permutation of a particular drug, and that will require a lot of combinations and permutations, because of which, again, the CPU speed will become bottleneck. So when we talk about big data in real life, at least one of these will become the bottleneck, and we will have no other option than having many computers parallelly solve the problem. We'll have to break down our problem and then break down our problem into parts, and then use many computers to solve it instead of relying on one computer. Okay. Now, quick question to you. Please answer in the chat window. Which components impact the speed of computing? Yes? CPU, memory size, or all of the above? That's right. Almost. So all of these components impact the speed of computing, whether it's CPU, memory size, memory read speed, disk speed, and disk size, and network speed. Okay? All of these impact the speed of computing. Okay? So it might look awkward to see network speed as impacting the speed of computing, right? But you will notice that when we are processing data these days, there's always something or the other being downloaded from the network. Specifically, if we talk about big data, some of the data will be in the network, and for processing, we might have to read the data from the network, and therefore communication with the network impacts the speed of computing. Now, we talked about problems, we talked about why big data is important today. Now, I want to discuss why big data is useful. Why do we want to process big data? Why don't we just say that, okay, this is hard, but it's not useful, therefore we are not going to use it. That's not. So that's not the reason. So that's not right. We have realized that the more the data, the better is the outcome. One such case was recommendations. Amazon's maximum sales, as in the sale actually went up by more than 25%. The day, more than actually 30%, as some people say, the day we started giving the recommendations. Recommendations not curated, but recommendations based on other people's preferences. So the way recommendation works is we find the similar users, we group them together, and then start giving the recommendations to each other. Now, recommendation was one of the very, very early use case in e-commerce, because it gave the people a great suggestion for buying, because of which the sales of an e-commerce company became better. All right. Now, there are multiple kinds of e-commerce, multiple kinds of recommendations. Like here, there are customers who bought this also bought that. The other kind of recommendations is wear it with this. Okay. These kind of recommendations are generally curated, but now they also have been automated by the way of data. So the more data we have, the better will be the recommendations. If we have less data or no data, then recommendations are just hand curated, Recommendations are just advertisement of things that we want to sell. But if we have good amount of information about people's purchases, then we can help the user. We can give great recommendations. We can provide more meaningful suggestions. The other use case of recommendation you might have noticed is of Netflix. Netflix figures out based on your watch history what should you be watching. Similar is the case of YouTube. All right. So we'll talk about how recommendations work, and we'll take a break here for 10 minutes. Break for 10 minutes and back by 8:45 a.m. IST. Please post the time in your time zone. Okay, so break for 10 minutes and back by 8:45 a.m. IST. Please post the time in your time zone in the chat window. That would help everybody else. All right, so it's 8:45 a.m. for me. Okay, we'll be back by 8:45 a.m. Just change by 1 minute. All right, so I'm back. Shall we start? There are 4 questions. Let me just quickly answer those questions. First question is, as part of the course, would we create projects and publish to Git to create a portfolio? Yes. So as part of the project itself, you have to fork the repository, update the code, and solve the test cases, and then publish that. Okay. A question from Prashant is that difference between Hadoop and MongoDB, and which is better with respect to big data. So MongoDB is great for structured data or semi-structured data, but Hadoop is a general purpose platform. The other thing is that in MongoDB, you don't have those much of flexibility of executing programs, right? You can only do the querying or execution using the MongoDB operations. But in Hadoop, you can actually use any program as in a distributed fashion. So that's why Hadoop or Spark makes a better choice than MongoDB. But MongoDB is a great choice when it comes to the distributed database, meaning a database whose records are distributed, meaning is being catered by many computers. A question from Prashant is, Java is necessary to learn Scala? No. Good question. So moving ahead, a question from Ravindra is, please explain about PySpark and Scala Spark combinations, and which scenarios will be good for AI, ML, and DL. So whether it's you are using PySpark or Scala Spark, you can use the library of machine learning for AI or ML in both. Whether you're using Python or Scala, you can use Spark's machine learning library very well. Okay, but industry is preferring the Scala one over the Python one when it comes to Spark, though usually people from Python background, people in machine learning use Python. So, but doesn't matter. It's just a slight one-line change. Okay, one-line change or slight change in the code to translate Scala 1 to Python 1. Okay, so whether you use Scala or Scala Spark, or you use Python Spark, PySpark, it's you can use the machine learning and deep learning very well. Okay, a question is, what is Hadoop? Hadoop is an ecosystem of tools. I'm going to talk about it. All right. So the recommendation that we talked about is basically suggesting what users may like based on the historical data of other users. Now, the way recommendations work is we take the data, we take the current data, current user behavior, and frame it in this format. We have the first column represents the user ID, second is the product ID, third one is the rating, and we feed it to a library or a project, a software like Spark ML, and it starts giving us suggestions in terms of that this user ID may like this movie this much. All right, so that's one library of Spark that helps you do the recommendations. Okay, you do the recommendations. All right, so now the second use case that is there in e-commerce industry is A/B testing, testing variation A against variation B. Okay, so in e-commerce, if you have noticed or not, if you take a look at Amazon, different mobile apps have slight variance. Okay, and what we'll do is we learn about the user behavior by doing changes to the components a little bit. Say, for example, when you take a look at the Amazon.com on the retail page, there is the color of the buy now button. That color of the buy now button has come by analysis. We showed different colors to people and we observed which one is making more sales. So, and we picked that one. So by the way of data, we can come up with product features. Here, by having the variations, like we have variation A and variation B, we are comparing the outcome of variation A and variation B. And based on that, we are taking a call whether variation A or B is better. Instead of having a very subjective discussion that this color is better, no, that color is better, here we are taking a call based on the data. So data can help us making great products. Okay, so which one will you choose, the variation A or B in this? Quickly, you can use the chat to answer. That's right, because the variation A is giving 23% conversion on equal amount of users, right? Variation A also is getting 50% of users, and variation B is also getting 50% of users. So the bigger the number of widgets or bigger the data we have, the better will be the outcome. Now, the other big data customers, almost everything in government is big data. When we talk about for the government, detecting the fraud, detecting the cybersecurity warfare, detecting and for the justice, by understanding the cases, the big data could be used to a very large extent, and it is being used. In telecom, again, almost everything is a big data. Customer churn, preventing the customer churn, network performance optimization, and calling record data analysis. Okay, so what does it mean by customer churn? When the customers are leaving you, they're leaving and going to your competitor, you can do an analysis and understand why are customers leaving you. And that way, once you know what exactly is wrong, you can work on improving it. Second is the network performance optimization. Network performance optimization is basically optimizing the network based on the historical data, that we see that there is a load here during these days, and therefore we should have more resources on this area. Then calling data record analysis, if we want to understand the user behavior, to some extent, we want to analyze the threats, we want to analyze the terror activities, we might want to do the analysis of calling records. So that's the third use case in the telecom. The fourth one is analyzing network to predict failure. Analyzing network to predict failure is something that is actually a very good use case. People do it to a very large extent. So because the network has certain behavior when the equipment is about to fail, or maybe like a couple of hours before that, and using that we can predict whether the network is about to fail or not, and we can take the prevention measures in order to avoid the failure. Right now, the next one is the healthcare and life sciences. Everything in healthcare and life sciences is humongous data. When it comes to health information exchange, almost every data, you have so many people, and every person's, even a single visit to the doctor and test is actually few gigabytes. Okay, so if you have so many people visiting so many doctors, you will have humongous amount of data generated. To store and exchange that amount of information, we require a big data system. And most of these companies are using the big data systems. because when the information is in petabytes, you would require a place where you can save it, place where you can share it with the other researchers. Second one is the gene sequencing. The gene sequencing is a very important use case whereby it requires a lot of computing. When you are doing gene sequencing, you are doing a lot of computing. And such kind of computing can be parallelized, can be distributed, and multiple computers can be utilized to do the gene sequencing. The third one is the healthcare improvements. In healthcare improvements, again, we need to understand the patient's behavior in more details. And for that, we require big data systems to keep all of that data intact. The fourth one is the drug safety. For drug safety, we do that A/B testing, the A/B testing that we just talked about. So the similar thing is done for many patients, right? Actually, one of my learners from IQVIA, he was actually doing the drug safety analysis using big data. And this drug safety is a very important aspect when it comes to the big data analysis. Now, there are many solutions, many big data solutions. Okay, there are many big data solutions such as there is Hadoop, there is a Spark, there is Cassandra, there is MongoDB, there is Google Compute Engine, and there is AWS. Right? So out of these, basically, these are the ones where it's kind of, you don't know what's going inside when you are using Google Compute Engine. You can just keep your data. Internally, they have their Google file system and some more other kind of systems where you can keep all the data. And here you have similar like cloud-based storage, cloud-based systems that you can utilize, both of these. The other one is to solve the big data problem. It's not really solutions. Everybody has a different meaning of the word called solution. So here, the big data solutions, when we say it, means that how do we solve of problem? How do we solve the problem of storing and processing humongous data, either by using Hadoop and Spark combination, using the Cassandra or MongoDB kind of combination. I mean, you can use them individually. And Google Compute Engine or AWS is, again, they provide the big data storages. They provide, let's say, big data databases to store humongous data and so on. So Google also provide that, and AWS also provide that. So that you don't have to create your own infrastructure and softwares. Now, out of these, my preference would be the Hadoop and Spark. The reason is that you can execute all kinds of workloads, and that has been the industry's preference for quite some time. When your data is in petabyte, you would want to keep it in your own Hadoop and Spark kind of ecosystem. And the data that is very that is needed by the customers outside your organization, that data, you put it on the cloud and make it available to people. But the data you gather about your users, the data that you gather as part of your application logs, all of that data people want to keep in the Hadoop and Spark ecosystem. And with respect to Cassandra and MongoDB, they are great if you are catering to your users. Imagine that you're building a website which requires really high-speed computation on a large scale. In those cases, you will probably go with Cassandra or MongoDB kind of infra. Okay, you will go with Cassandra or MongoDB kind of NoSQL storages in order to cater to your users, because Cassandra or MongoDB provide you database like software which basically runs on multiple computers. So we're going to focus more on Hadoop and Spark ecosystem. All right, so let me go ahead and just take a 10 more minutes on describing Hadoop, and then we'll take some questions, and then we'll again go ahead with the theory, and then with questions. All right, so what exactly is Hadoop? Okay, so Hadoop was basically created long back by Doc Cutting. He was working with Yahoo and was trying to build a search engine like Google, but he was not able to proceed because he realized the bottlenecks, he realized the limitations posed by the existing softwares and existing computers. Okay, so he was joined by Mike Caffarella, and at the same time, Google published these three papers, the legendary three papers. One was Google File System, other was Google MapReduce, and third was Google Big Table. Okay, so if you take a look at these three papers, these are quite a big deal in the ecosystem. I'll just say Google File System, right? So you can see this paper specifically, this paper. Okay, so it's a 2003. It was published by Sanjay Kemawat and these people, and this is what made Google File System, then Google MapReduce, and then Google Big Table. Those three papers were the inspiration for Hadoop. And it was named after the toy elephant, and it was an open source, specifically Apache open source. It's powerful, popular, and well supported. It's a framework to handle big data. And the core idea about Hadoop is that it is for distributed, scalable, and reliable computing. What's the difference between the three? Distributed means Hadoop, all the components under the umbrella of Hadoop. Soon after it was published, Hadoop was in the beginning only three products. One was file system, other was MapReduce, and third one was the HBase. So after it became popular and people started using Hadoop, then a lot of more and more components were added to it. And because of it, it became an umbrella term. Hadoop became an umbrella term whereby there are many, it's a suite of components. Now, all of the components under the umbrella of Hadoop are for distributed computing, meaning they all should run on many computers. They should be able to break down we should be able to break down the problem and run these tools in parallel on the cluster. Cluster means a group of computers. Second, they should be scalable, meaning today we have 10 computers, tomorrow we might have 20. Day after tomorrow, we might have like 50 computers, and they should scale well. They should be stretchable, meaning you should be able to add more and more machines, and still everything remains the same. We don't have to change or transport the data from here to there, and so on. The third one is reliable, meaning in case some of the hardware fails, in case network connectivity fails, when you have connected many computers, there are many things that could fail. Some of the things that could fail is that few computers went down, the network went down, and so on and so forth. So these tools should be able to handle these kind of outages, these kind of failures. So all the components under the umbrella are basically distributed, scalable, and reliable. They are basically for distributed, scalable, and reliable computing. All right, and most of the components, almost all the components under Hadoop are written in Java. So that's the Hadoop. Hadoop as of today is an ecosystem of components. There are multiple companies who are supporting. One is Hortonworks. Hortonworks basically has something called HDP, Hortonworks Data Platform. It's a combination that has Apache Hadoop plus Spark. And along with that, there is Kafka in this suite of components. Then the next one we have as part of HDP is Ambari. Ambari has Ambari has the provisioning and workbench. Provisioning as in it's a place using Ambari, you can create the entire cluster. It's actually pretty seamless. This is how we have installed CloudX Lab also. We install Ambari and Ambari installs everything else. That's called provisioning. And Ambari also provides a workbench whereby you can do the work. The work as in you can interact with the various components. Okay. The second one is Cloudera. Cloudera is, again, Cloudera provides its own, distribution. It has, again, a combination of Hadoop and Spark. It provides Cloudera Manager for provisioning, and it provides something called Hue as a workbench. Okay. And this third distribution called Mappa, that's not much in use. And also, Hortonworks and Cloudera, they have been combined today as a single company. All right. In case you are trying to host your own Hadoop in the cloud, you can do in the cloud using Azure. Using Azure, there's a package called HD Insight, which is essentially Hortonworks HDP, and you can install it. And you can extend that using with .NET and with Java. Okay, so you can also install on Amazon. All right, I'll do the hands-on as we talk about in the next chapter. Okay, so you can take a look at this is what we have done for our learners, that in case you want to install your own Hadoop, you can follow these instructions. All right, so we've installed CloudX Lab on Amazon EC2, and here are the instructions if you want to install your own lab. Now, the third one is instead of installing Hadoop, you could just use Amazon service called Elastic MapReduce. That's only for MapReduce, one component of Hadoop, not everything. Okay, so these are the options, and then using Google Cloud Platform, by using the same strategy like this, we can install the Hadoop on the Google Cloud Platform as well. All right, so let me talk about the various components, and I'll also do a bit of hands-on, and then we will take your questions. Okay, then I'll take your questions. So let's get started with the components. Please feel free to ask your questions as and when you get a question. So do not wait for me to finish. All right, so the core of in case of Hadoop ecosystem, the one component that we will first talk about as part of this course, in case of Hadoop, there is this thing called Zookeeper that is for coordination. Using Zookeeper, you can Zookeeper is not really part of Hadoop ecosystem, but almost every service uses Zookeeper indirectly or indirectly. Using Zookeeper, you can interact with using Zookeeper, the services can keep track of who is where and what is doing what. Okay, so every service reports and informs the Zookeeper, and Zookeeper provides the information about the services to each other. So you can think of Zookeeper as a central database or central registry of these services in the ecosystem. All right, those who are interested in doing the hands-on on Zookeeper, they should take a look at, say, CloudX Lab here. Okay, and here. Okay, so must be somewhere here. Okay. Okay. So in your course, you will find the, never mind, I think I'll just move ahead. You'll find the Zookeeper overview. Okay. And let me just get started with Zookeeper. Now, okay, so I'll just show you how to use it, and I think that'll be good enough. Lots of people are asking for hands-on. Don't worry in case you are not able to get this. So you can just sign up for free, and you'll get the lab, and there you can just log into the web console, and here I'm logging into my account. Okay, so let me increase the font. So you can interact with Zookeeper using Zookeeper client, and that's about it. So these are the various nodes, just like file system, you can interact with them. All right. So that's about the Zookeeper. You can get set the values and take a look at this. So take a look at Zookeeper. I'm just going to give you a point of starting. Rest you can do. The second one is the Hadoop distributed file system. Hadoop distributed file system, it's just a normal file system. What's a file system? File system has files and folders, right? And you upload the files and into a file system, right? You copy the files. So file system, there have been lots of file systems in the history. What is so special about Hadoop file system is that this file system runs on top of so many computers. It runs on top of so many computers. And that way, it can provide virtually infinite size storage, right? So you can keep on adding more and more computers when it's about to be filled, and the storage keep on increasing. Like, for example, here, I can just show you. If you go into Hue, Hue is the component from Cloud Data. So what we've done is we have taken best of both worlds. We've taken from the Hortonworks and we've taken from Cloud Data and merged them together and created Hue. Created the CloudX Lab. In CloudX Lab, you'll get Ambari as well as Hue, both the components, one from Hortonworks and one from Cloud Data. And so I'm going to talk about the Hadoop distributed file system. Hadoop distributed file system is just like any other file system. And if you take a look at the files here, if you go click here and then go to files, this is how it looks like. These are my files and folders that you see here. This is Hadoop distributed file system. Every user gets their home directory like this, and every user can upload the files using the browser. In case you are a fan of the command line, you can use a command called Hadoop fs to talk to Hadoop file system. Take a look at these various commands. All right. So this way we can interact with the file system. We can download and upload it. The important part to notice is that these files are not necessarily stored on the same computer. They might be stored on different computers, right? We have four or five nodes running currently, and those four or five computers are providing these storages. This might be on one computer, this might be on another, this might be on another, and so on. And there's a copy of these kept parallelly, and all of that magic is done by Hadoop file system. You don't have to worry about it. The moment you install it, you get the file system, you can start uploading the data, and you can start your work. And you don't have to worry about, taking care of dividing the work or copying the files from one here to there. So Hadoop distributed file system is the base for the entire Hadoop ecosystem. Every other component keeps their data in Hadoop distributed file system. It is the base. This is what we call the data lake also, or you can say that data lake can be implemented using the Hadoop distributed file system. Now, the second component that comes into play is Yarn. Yarn is like operating system, like we have Linux, we have the underlying operating system. Usually as engineers or developers or as a user of the Hadoop ecosystem, we don't interact with Yarn too much. We don't interact with Yarn too much. There is no way of interacting with Yarn because we talk to Yarn by the way of other tools. The second component of Hadoop ecosystem is MapReduce. MapReduce is the one that does the processing. So we structure our logic, our project in the form of what MapReduce wants us. So we hand that the program to MapReduce. MapReduce executes that on Yarn, and Yarn executes it on Hadoop distributed file system. And then there is Spark. Spark can also run on top of Yarn. Spark can also run on top of Yarn. All right. So if you are interested in running MapReduce, you can take a look at our repository in GitHub. There we have posted examples of running MapReduce. You can take a look at that. And Spark is a great tool. Using Spark, we can do all kinds of processing. I'm going to go more detail on Spark. Then a lot of times, instead of only uploading files or downloading files, we might need to work on records, just like a database. In that case, you use HBase. HBase is a tool that provides kind of a data store in which we can keep the data in the form of rows and columns, not in the form of files. That makes it possible to do lot of fast operations. And HBase stores the data in the Hadoop file system. Just like any database, it stores the data in the operating system's file system. Similarly, the HBase stores the data. HBase stores the data in Hadoop file system. I'm going to show you quickly what it means by HBase, so you can actually either use the command line to interact with HBase, or you can probably use from here. Okay, I don't think it works. Okay, I'll just show you from here. So you can just say HBase and shell. Okay, and here, when you say list, it shows all the tables. Let's say this one. Okay, and we can do scan. All right. Okay, so this is the data in his table. All right. So this is essentially a very crude interface. And here you can take a look at the various tables from here. There's no rows to display here. All right. Okay, so this is this is the H base in which you can change these values, you can edit these values, and so on, and you can, right? So the data is in the form of a table, roughly a table. Okay, we learn about in more detail about HBase when you go through the HBase tutorial, HBase chapter. All right. Now the next thing is the Hive. Now for everything we can't really code MapReduce. Whenever we want to process things, we can't really write the code. For that we have Hive. Hive is again, Hive lets us write the SQL queries, and these queries are executed by the way of Hadoop ecosystem. So the work is divided onto multiple computers to be executed on the Hadoop ecosystem. So Hive asks MapReduce, MapReduce asks Yarn, and Yarn divides the work. The next one is Piglatin. Piglatin was kind of SQL alternative, but it did not fly much, so people don't use it. The Moth was a machine learning library, but it has been largely replaced with the Spark ML. When we have a classic project, we have just too many things to do. In those cases, it's important to create a project out of it and then execute that using a workflow engine, such as Oozie. You can interact with any of these components, either the command line, like the Hive case. I'll just show you Hive. So Hive I missed here. So you could just go here and click on query, and you can see that I have been able to execute the queries, right? So I can just say show tables. Okay. The important part, the way it differentiates from classic SQL is it can do processing on petabytes of data. How? It divides it divides the work onto multiple computers which are in your network, in your cluster of Hadoop, and it gives you the results. And that's the amazing part about the Hadoop ecosystem. So this is the way you can interact with the Hadoop file system by the way of Hive. You can you first have to create a table and then map the table to a file or data stored somewhere in HDFS, and then you can do the rest of the processing. All right, so now I'm going to talk about Oozie use case. So let's say you want to build a recommendation engine. Using Flume, you will push the data to HDFS, and then once you have the data in the HDFS, you will do the ETL. You will do the ETL using Spark, Hive, or Pig. Using Spark, Hive, or Pig. And you store the results. So this is the ETL phase. Imagine you want to build a recommendation engine. What is a recommendation engine? We want to, let's say we are running an e-commerce company, and what you want to do is you want to show the recommendations just like Amazon, saying that this user might also like this, right? So what we'll do is, first of all, we'll use a tool from Hadoop ecosystem called Flume. This Flume will keep running on all the machines on which our website is running, and all the logs, it will keep on pumping to a central place called HDFS. Then we will run this ETL tool called using either Spark, Hive, or Pig. Generally, people use either the Hive or use Spark for doing the ETL, and it will translate the logs into a tabular form, saying that this user would like this product this much. We'll convert that raw data, the text data from the logs into a tabular form. And once that's done, then we hand over that tabular form data to the machine learning library of Spark. And that this library will give the recommendations and keep it in the file system. Now, first one, just copied the data, the Flume. Second one, translated that raw data from unstructured to structured. And then using the structured data, the ML lab gave recommendations. And using those recommendations, we can show it to the user. But to show it to the user, we will have to take that data from Hadoop file system and push it to MySQL from where your web application will display the results to the end user. Okay, so this is the example. If you have to build recommendations like Amazon, this is the workflow you will follow. Again, this is an example of pipeline, you can say, and this is the way we go ahead. A question is, why not we use Airflow? We will be probably updating this course to include Airflow and observe that will it be useful or not. All right. Probably will be adding in this particular course the Airflow. Okay. So we have to run it daily using Oozie workflow. Okay, so all of these steps that you see here, there are quite a few steps: copying the data from using Flume from web servers to the HDFS, then doing the ETL, then generating the recommendation, and then copying. You can see that this is the machine learning part. This is the only machine learning part, and this is actually, say, 5% of the work. Remaining 90% actually goes, 95% actually goes here. The time consumed in solving these problems. So this kind of, when you have so many things to do, it's better to just create a workflow using Oozie or other tools. And earlier there used to be Azkaban. I used that one for one of my projects, but then we moved into Oozie. So this is a classic example of how to build a recommendation engine. All right, so I'm going to talk about Apache Spark quickly, and then I'll take your questions. All right. So Apache Spark is essentially really fast MapReduce. So when we talk about this, right? So this particular component is what Spark is competing with. Spark is competing with this particular component called MapReduce, which is Hadoop, which is basically a component from Hadoop. So Spark is essentially a really fast MapReduce competitor. It's 100 times faster than Hadoop MapReduce in the memory. It's 10 times faster on the disk. It builds on similar paradigms as MapReduce. It builds on similar paradigms like MapReduce. It is very well integrated with Hadoop. All right, let me talk about the ecosystem of Spark. So Spark is basically for doing the processing of data. Spark does not provide any storage. Spark does not provide any kind of storage, whether structured or unstructured. It is basically for processing. Now, since Spark also runs in a distributed fashion, meaning it runs on multiple computers, it can run on a multitude of computers. So we can either run Spark on top of Hadoop. If you, let's say, you are in an organization which you are already having Hadoop ecosystem where they had installed, let's say, they had got, say, 100 computers and installed Hadoop on it, and it was working perfectly fine. You can run Spark on top of it. Spark can run on top of Amazon EC2. Spark can run on something called Mesos. Mesos is similar to Hadoop's Yarn. Hadoop has Yarn. The Yarn is like a distributed operating system which can help you in running things in a network. So the fourth thing is standalone. So Spark can run standalone. In case you do not have any any cluster as of now and you want to create a fresh new cluster, you can use Spark's standalone mode to execute that. Also, Spark comes in a local mode as well. You can just download Spark and it will run very well on your desktop as well. Okay, so Spark doesn't necessarily need a distributed environment. It can run in a local environment also. Now, using Spark, we can read the data. The core of the Spark has these functionalities: the ability to execute anywhere, the ability to read the data from HDFS, HBase, Hive, Tachyon, and now it's called Elixir and Cassandra. So using Spark, you can read the data from all kinds of data sources and all kinds of formats. Now, since the core programming using while loop and MapReduce doesn't really suffice, therefore, Spark team created these libraries. One of them is called data frames, which let you represent data in the form of tables and execute queries on that. That's called Spark data frames. It's actually very powerful. And then we have streaming in case you want to process data every second or so. You can use streaming. So streaming is basically for the cases when you want to continuously process the data. You have the Twitter feed coming in and you want to display the analytics on that tweet. So you can do that using Spark streaming. Then there is third library, which is MLlib. MLlib is a very powerful library. MLlib is the only library which is open source and is so powerful to do the machine learning. Machine learning is making machines learn from the data, making machines do the predictions by learning based on the data. The recommendation engine is one classic example. So using Spark MLlib, you can do a lot of complex tasks. GraphX is for graph processing. GraphX is for graph processing. Using GraphX, you can do the processing using of graphs. When your data is in, let's say, Facebook form, in the form of like a big graph. Let's say you have friends, the friends have friends, and so on, and you want to find out how many common friends you have or who should be given the recommendation to become a friend. Those kind of works can be done using GraphX. Now, the most important part out of all of this, that Spark made it possible to use any programming language, any kind of language. So as of now, the languages that it supports is Scala, Python, Java, R, and SQL. Along with that, they have launched a Go version also. So the language, the programming language is not an entry barrier. So if you are comfortable with Python, Scala, Java, Spark R, or SQL, you can do all kinds of processing using Spark. Okay. I'll talk about a typical workflow in a moment, or maybe let me just complete that one also. It's actually pretty useful to understand this. Okay. So in typical workflow, what we do is we first of all gather the data. Gather the data using Flume, HBase, HDFS, Kafka. Kafka is again a queue kind of a system whereby you put the data from one end and you listen on another end. Okay, so let's say you want to inform all the stakeholders in a company that this particular record has changed. So all those stakeholders will listen to a particular topic and you will write on that topic, just like Twitter for programs. Okay. So people can subscribe to the topic, and the programs can subscribe to the topic and listen on the topics, and program can publish on the topics. So the first thing is the gathering the data. That's the first phase when you are building any kind of big data solution. Then it's ETL, we call it cleaning the data. We need to format this raw data to convert it into a tabular form. For classic small data, Informatica and other things are good, but when it comes to big data, Spark and MapReduce can do a big job. To do the basic analysis, like finding the statistics and so on, you can use Hive or Spark SQL to do the basic analysis if your data is big. And then, using the machine learning algorithms, you can give predictive analytics, or you can give prescriptive analytics, or you can give the recommendations or machine learning using machine learning algorithms. And for that, you can use Spark MLlib, Mahout, GraphX, scikit-learn, R. These are typical workflows. And though scikit-learn and R is good for small data, but you can execute all of those programs on top of Spark if you are able to divide the logic. And once you're done with that, you have to, maybe you want to improve the performance, you want to further optimize the ML algorithms. The last one is, once you are done with doing the machine learning and the predictions and so on, you can move the results to the production. For doing that, for optimizing machine learning algorithm, you might need the knowledge of TensorFlow, linear regression, or let's say machine learning algorithms. And for moving the results to the production, or moving a product to the production, you might require the knowledge of exposing the REST APIs, building Android apps, or learn the DevOps. There is something called developer operations. It's a very important field of computing. So using you might have to learn DevOps. So this is the typical workflow, and these are the various tools that are needed. And we have the trainings for the TensorFlow, the machine learning, as well as the machine learning, as well as the data engineering. So this phase is generally referred to as data engineering till this point. This phase is referred to as the machine learning or deep learning, and this phase is referred to as DevOps. Okay, so this is how we generally look at a machine learning project. Okay, so let me just try to answer your questions now. Okay. A question from Neil is, sorry, I missed your answer related to the Git project. So yes, your question was that whether we will be building the portfolio as part of this course using Git project. Yes. You'll be basically creating your own Git project by forking our repository, and then you'll work on that. A question from Alan is that big data applications only for big companies, MNCs? No. There's a lot of public data available. You can build the data application, big data applications, using the public data available to you. A question from Anup is that Google Cloud is a big data solution. So you can install, your Google Cloud provides the storage and other things. That's actually good for big data development and big data processing and storage. A question from Iraqi is that, is Spark evaluation of MapReduce or completely new framework? What is the main advantage of Spark over MapReduce, and due to what? So Spark is not a replacement for the entire framework. Spark is a replacement of, say, MapReduce. MapReduce, and hence the Hive, and hence the Mahout, because those are the processing components of Hadoop. So Spark provides very powerful ways of doing the processing, whether it's like volume, whether it's like processing the volume, processing the velocity, like fast moving data, or processing the variety, all kinds of variety of the data Spark can process. And Spark is approximately 20 times faster than Hadoop MapReduce or any other frameworks. A question from Arun is, GCE and AWS just provide the platform to run Hadoop. Google Compute Engine and AWS just provide the platform to run Hadoop. Yes. So yes, they also provide their own customized version of MapReduce other than a platform to run Hadoop. Okay, like for example, Amazon MapReduce is there. They call it Elastic MapReduce. A question from Ranu is that following the merger of Hortonworks and Cloudera, which distribution should we choose? Okay, I still prefer the Hortonworks distribution. Okay, because it's far more easier to install, and generally you should just go ahead with Hortonworks and install the Cloudera Hue. Follow that YouTube video, probably that will guide you. All right. A question from Ankit is there hands-on exercise in this session? So that was a very basic one. I think what I'll do is I'll just show you how to use Spark quickly, so that right, you get the picture. So if you are in the lab and you're in the console, let's say here, I'll just exit from HBase. Okay. If you want to use Spark in Scala, you can just use Spark shell. Okay. Okay, don't get intimidated by this. So this is basically launching Spark. So this is an interactive console of Spark. I can load the data using this. So I'm saying I'm using the sc.txt file. I'm trying to load this data from say Hadoop file system. Let me just show you which data I'm trying to load. Okay, so what we're trying to do is I'm trying to load some data from HDFS. Okay. All right, so let's take a look at this folder. Okay, so let's just take a look at, say, 10 records from it. So you can see that we have read 10 records from this file. And this file is where? This file is in HDFS. So if you go here, okay, if you go here and go to the top, or you can just edit this location, okay. So you can see there's a file called big.txt and this is small.txt, okay. So if you want to specifically mention that, hey, we are looking for only a particular file, so we can say, let's say, small.txt. And then we can say data.collect. You can see this is a small file. This is a cat, there is a rat, and that's it. Okay. So if you take a look at this file, this is what it is. Right? So we are able to read the data from here. Similarly, if you are if you want to use Python Spark, you can just say PySpark, and I'll just copy this code, the same code that we used. Okay, I'm just going to use, say, this particular code as is. So this was in Scala, and this is in Python. Okay. You can see Scala is very similar to Python, right? So that was Python. And similarly, you can also interact with Spark SQL. You can interact with say, the MLlib. You can just import MLlib in your project and start using it. Okay. So that was a quick hands-on, though the hands-on was not something that we planned. This one. A question from Prashant is HDFS is what we call data lake. That's right. HDFS is just one example of data lake. Can we use Spark and MongoDB or Cassandra? If so, why is it not popular? Can we use Spark with MongoDB or Cassandra? Yes. So we can read the data from all kinds of sources into Spark. Just that it's actually popular. Quite a few people use Spark with MongoDB and Cassandra. MongoDB and Cassandra are used in cases you need to serve your users instantaneously and so on, while Spark and Hadoop are used in the cases when we want to do the analysis. That analysis may take a long time, right? And you don't want to make your users wait. A question from Ranu is that why not Airflow? Yes, we should be trying out Airflow in the Cloud Scala. Question is, what is a workbench? Workbench is a terminology given to the things on which the people can work. So Hue is a workbench because there we are able to interact with various components online. So that's why we call that as a workbench. The question is, as a beginner in Hadoop, are we required to learn all these technology in Hadoop ecosystem, or what technology should you learn first? My suggestion will be just know basics of Hadoop file system, and know basics of, say, Hive, and then learn Spark. Okay, even if you don't know Hive, you can just learn Spark. Basics of Hadoop file system is good enough, and I would say that once you know the basics, rest of the things will become easier. Okay. A question is, have you encountered any use case scenario that you could not use Spark because of memory bottleneck, like Hugh's RDD data frame could not fit in the memory and have to depend on MapReduce only? Good question, good question. So question is that, is there some case where you have to go back to Hadoop MapReduce instead of Spark? The answer is no, because Spark lets you deal with both. If you understand Spark correctly, you will have the ability to uncache things, use memory as much as you want, use memory as minimal as you want. So Spark doesn't really consume a lot of memory. It just uses the memory in a very optimized fashion so that you are able to do a lot of, you are able to fine tune the Spark application as per your needs. Okay, so quick answer is no. A question from Equip family is that any training on using Git or Bitbucket? So we'll just give you a basic overview on how to clone and so on. And that is basically on the day zero, day one, when we are starting with the Scala one, because every code we have kept in the GitHub only. Okay, so the basics, yes, we'll be talking about. A question from Dislas is that, does Google allow access to the big data they have collected? If yes, what's the process? They don't. Okay, they don't. The only data they share it with the governments. So you can send the request if you're part of the government. At most, they can give you your own data, but not the big data. Question from Prashant is, Kafka works like a data forwarder, or is it similar to Minify? It's basically the enterprise message bus, distributed enterprise message bus, meaning you have on one end, so the way Kafka works is, let's say this is Kafka. On one end, user will be speaking on a topic. It has many topics. So on one hand, users will be speaking. On the other hand, the listeners will be listening from it. Okay, so here the many users can talk on a topic and many users can listen on a topic. All right, so that's the idea. Okay, Question is, do cloud providers provide Spark as part of Hadoop solution, or is it need to be installed, configured separately? Good question. Both Hortonworks and Cloudera both provides Spark along with Hadoop in their distribution. A question from Neil is, do we need to learn probability and statistics for using or learning Spark ML? Not really, not really. Okay. So whenever required, only those parts you need to just take a look and understand. That's pretty much. Okay. A question is, so in essential workflow, in the workflow is to transform data from unstructured to structured and then use the ML business logic to get results like recommendations you wanted. That's correct. That's correct understanding. Great. All right. A question from Ravind is, can we use HD Big Insights? HD Insights, I think, or is it Big Insights? HD Insights and Hadoop, how can we start to learn and get experience? So HD Insights, the one that you have on Azure ML, it's actually basically the normal Hadoop ecosystem that they have renamed. So my suggestion is that you start learning the Hadoop normally, and exactly the same concept apply there. There's nothing new over there. Okay. So this class could be quite useful to you. So my suggestion will be to take the self-paced on Hadoop and join the live on the Spark. Okay. In Spark, when you manipulate data in RDDs, it makes a new RDD. Isn't that waste of memory? The RDD is not really a memory. It's just a graph. It's just a order, like the way you place an order, then the waiter is taking your orders, right? It's just that order list. Okay, it's not really food that is there that you said that get me, you know, the menu, the when you are placing an order and the waiter is taking your orders in a restaurant, it's not really food, it's just orders. Similarly here, when we talk about we created this RDD, that RDD, it's not really data, it's just the graph of the commands that you have given. Okay, good question. So question from Avinash is Spark caching an important term in real project in companies? So Spark caching has been badly abused because Spark lets you do the processing in the memory, and it has been badly abused by many. So important part is to understand when to use the Spark caching correctly or not. Okay, so when you are learning Spark, make sure that you understand how exactly you need to do caching and when exactly do you need caching. Okay, a question from Subabu is that I know Unix, Linux, Unix shell script, SQL, and I work on Azure Cloud. So for future growth, which profile is best, like ML or big data? All right, good question. So a common question that I face is that, hey, should I learn big data or machine learning? And this chart, the workflow that you see on the screen, shows that if you know about machine learning algorithms, you will be able to solve the real problems. So Babu, you will be, because you know, you are comfortable with Linux, Unix shell script, that means you will be able to deal with this, right? And since you are again comfortable with the basics of Linux, you'll be able to deal with this, gathering the data. Then you know about the basics of SQL. So using Spark SQL or Hive, you will be able to do some part of it. And this part is something that you will have to learn. And this part is something that you have to learn. Okay. And of course, if you are using Hive, you will have to learn basics of Hive. If you want to learn about Spark, you might have to learn about Spark. Okay, so for you, I think the way I give a suggestion that it's not about and or. It's not about or. It's not about this or that. It's about both. You should generally aim for start with the career as data engineer. Okay, start with a career as data engineer. Okay, data engineer, and then move on to the ML engineer. Okay, so as part of the data engineer, you will be responsible from here till here. Okay, and as part of ML engineer, you'll be so till here actually, and as part of this, you will be responsible for the entire pipeline. So for being good at data engineering, you need to know the big data and the ecosystem. And for being good at pushing the machine learning models to the production, you will need the knowledge of machine learning. Okay, so ML engineer will understand these parts, data engineer will understand this part. If you know both, it's actually pretty good. All right, so I hope I was able to answer your question. A question from Anup is, big data solutions is no limitations. The only limitations are in terms of the expectation. Sometimes we want the distribute as well as consistent, as well as the no delay. In those cases, the big data solutions have limitations. Read about something called that. What was that? Brewer's problem, and you'll know that you can't achieve all the three things: consistency, and the CAP theorem, the consistency, availability, and partition tolerance you can't achieve. Therefore, there is a limitation. In case you move to the distributed system, you might have a slight bit of inconsistency, but it will be eventual consistency, meaning after a while, everything will be okay. So those are the limitations of big data solutions. You should read about CAP theorem. It's called CAP theorem. Okay. A question from Arun is, in Spark, we work directly on server, or we need some client to be installed? All right. Does Spark has any GUI based client? No, not really. Spark doesn't have any GUI based client. Also, you can install Spark locally and work on your local environment, and that should be a good way to get started. Okay. All right. A question from Dilip is, how do you schedule job outside of Hadoop Spark? Outside of Hadoop Spark, you can schedule job using, say, the normal scheduler like cron tab. There is a Unix cron tab, and there are quite a few job schedulers available. Okay, but we prefer the cron tabs. All right. A question from Ravinder, can you please give us some idea about ELK and Neo4j tools? Neo4j is basically a graph database, and ELK is a way of, is a stack of log processing and so on. Okay, so those are the stacks. And I can probably, if you leave this comment on the discussion forum, I would love to answer this in more details. Okay. A question from Anup is, who are data scientists? So data scientists is something of a really big term. And at the same time, the term has been badly abused. Everybody who is part of some ecosystem here is called data scientist. Okay. Though the term was very different when it was coined, the term was to represent somebody who could solve who could solve and build solutions around the data, understanding the domain knowledge, understanding the maths and statistics behind it, understand the machine learning and computing around it. So data scientist was that term, but today it has been kind of abused. Okay, a question from Anup is, Microsoft Azure is big data solutions. So yes, Azure provides you a way to do big data solutions by installing the Hadoop or Spark on Azure. A question from Neil is, what is used to implement security in big data solutions? So underneath, most of the big data solutions share the same security strategies as Linux. So each of the ecosystem comes up with their own security implementations. Take a look at Cloudera or Hortonworks ecosystem, and you will get a decent amount of idea. A question from Gaurav is, does the self-paced course cover the same content as instructor-led training? Yes. The content is same, just that the one-on-one questions are something that is there in instructor-led. So my suggestion will be that come over to Big Data with Spark online course, this particular course. And the link has been posted by Sweta. You can use that link to enroll. And not that one, actually, you should take a look at this particular course. Okay? You should take a look at this particular course, this one. So this is a course which I strongly suggest to the learners, that this course basically starts with, just take a look at learning path. So it basically has two parts to it. One is big data with Hadoop, and other is the big data with Spark. Okay, so what you can do is you can take the Hadoop course as self-paced, and the Spark course is live. That also you can do. Okay, so you can enroll for that. And this essentially has two parts to it. One is Hadoop and Spark. And in Spark, we basically start with this, the one that we did today. And then we will do the Spark introduction as understanding why exactly Spark. And then we will learn about Scala. We'll learn the programming language called Scala. Then we'll learn about Spark basics. And there are more chapters here. The chapters we need to, let me just show you the chapters. Okay, the chapters that I'm going to follow are these. Okay. Also keep in mind that the course would update as per the current trends. So some of the topics that I mentioned here, you might get more topics than these, and some might get discarded. All right. So these are the chapters that we follow. We start with the introduction, then we basically give you these free understanding of free courses on these topics like Linux and regular expression and so on. And then we have a recap of big data. We'll do the recap of big data. And yeah, recap of big data. And then we'll have a Scala basics. Okay. And after that, we'll have Spark basics. Then we'll learn how to write Spark applications and so on. So you can enroll into this course. You can just click on enroll now and enroll. All right. Okay, so that's pretty much for today. I'll just answer a couple of more questions. And is there any cloud platform which can be used for free trial? Most of the platform need. What do you suggest? So actually, the thing is here, you can just try CloudX Lab. Okay. And do you mean to say that between Google and Azure? So this one will require a credit card, but we won't deduct any amount from your credit card. Okay. We won't deduct, as in there'll be a $1 transaction which will be reversed. Okay. A question from Neil, would this course help in clearing CCP? Yes. So Cloudera CCA certification, we call it. So this course aims for that kind of certification. So you can take a look at that. And we also provide our own certification. A question from Prashant is, can I create my local test environment by installing Hadoop and Spark to continue with this learning? Yes, you are free to do that. We'll help you with that. You can install the virtual environment as well. All right. All right, so thank you, everyone. It was wonderful to have all of you in this session. And I hope this was useful for you. All right. So thank you, everyone. I look forward to see you next Saturday. We'll let you know about the plan. So you can enroll in the course if you're interested. And this course is going to be quite useful to you in general. Feel free to recommend the course to your friends or family members. So a question from Arun is that, do you have DevOps course? We are coming up with the DevOps course soon. Our question is the next session free? The next session is not entirely, only the first session is free. From next session, you'll have to enroll for the course. All right? All right, so I look forward to see you. Thank you, everyone. I'm really happy that more than 60 people were in the session for 3 hours. That's a rare thing, specifically an online one. I'm glad to have a wonderful audience, and I look forward to see you in the course. Bye-bye. Have a great day. Thank you, everyone. All right, so you can enroll for the course if you are looking forward for learning the Spark or Hadoop. Bye-bye. Have a good day. Stay connected. Stay on our the discussion forum.